We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
Guys, let's go over the stats lesson 4.8, combinations and probability. Learning targets. After this lesson, you should be able to compute the number of combinations of n individuals taken k at a time. Learning target number 2, use combinations to calculate probabilities, example 2a and 2b and 4 in this lesson, and then use the multiplication counting principle and combinations to calculate probabilities. Let's look at learning target number 1. Let's review really quickly. Recall that a permutation is a distinct arrangement. Think of a race, right? You really want to know who finishes first, second, and third to award the medals. So order is important. With permutations, order matters. Sometimes we're just interested in finding out how many ways there are to choose some numbers of individuals from a group. But we don't care about the order in which individuals are selected. A combination. This is our keyword. Let's make it a little bit thicker. Or a combo is a selection of individuals from some group in which the order of selection doesn't matter. If there are n individuals, then the notation n ck represents the number of different combinations of k individuals from the entire group of n. I'm just thinking about this for myself, right? When you think of a combo from In and Out, I really don't care on the tray what comes first. The hamburger, that's my hamburger, green hamburger, the french fries, or the drink. Well, of course, they give you the drink first, but what I'm trying to say, it doesn't matter if the french fry comes first and on my tray, or the drink, or the hamburger. I just want it all, right? That's what we're trying to say here. So let's go ahead and... So the big question is, order important? Think about that. Excuse the sniffles. Okay. So let's do a summary. We learned about previously that permutations and the question is, does order matter? And the answer over here was yes. Right? Think about a race that we did like last time. Maybe the number of votes determines who is the cabinet, right? Most popular gets president. Second, vice president. Third most gets historian or treasurer. And that formula we had n, or p, permutations, n, do n factorial over n minus k factorial. But when we're thinking about combinations, again, think about the combo when you go to Carl's Jr., right? Does order matter? The answer is no. Let's write those examples that we had. Carl's Jr. And that formula, C, combinations, total, and how many you're picking, n prime, n factorial over n minus k factorial. But look at that. The formula looks exactly the same, but the only thing that's different here is k factorial. There we go. Okay, so that's a summary of permutations and combinations. Permutations, order matters. Combinations, combos, they do not. Let's try an example here. Who screams for ice cream? Mr. Ing loves ice cream. The local ice cream stand offers a triple scoop dish of ice cream. The stand has 15 different ice cream flavors, and Mr. Ing always chooses 3 different flavors for his dish. How many different sets of 3 flavors can Mr. Ing choose from in his dish? Okay, ask yourself the question, does order matter? The ice cream can come in a variety of ways, right? Maybe you have blueberry first, or maybe blueberries second, or blueberries on the far right. And maybe you have like mint, spinach ice cream. Maybe it's on the far right, or maybe it's in the front. And then maybe you have, yes, I did say that, tomato ice cream last, or first, or the middle. Doesn't matter. You get 3 different flavors, so it doesn't matter there. So how many can we are we choosing from? Let's choose a different color here. Well, 15 flavors to choose from, so n is equal to 15. So we said the order does not matter, therefore it is a combo. Just going to write down that formula. And how many can we have there? What can we choose from? Well, only 3 different flavors. So this would be our k value. So n is 15, k is 3. We're basically going to get this as our formula. 15 factorial over 15 minus 3 factorial, and then 3 factorial. Remember what the factorial does. That's just 15, well, let me expand this one. 15 minus 3 is 12, so it's 12 factorial times 3 factorial. So essentially you're going to get 15 times 14 times 13, all over, whoops, I should say 12, 12 times 11, right, all the way down. And then you have, just highlight it here in red, 3 times 2 times 1. So 12s, 11s, 10s, and all of that will cancel. And so essentially all you have is just 15 times 14 times 13 over 3 times 2 times 1. The answer is going to be 455. There are 455 different sets of 3 flavors that I can choose from. All right, you try example 1B and then press play when you're ready. State's Department of Transportation plans to develop a new section of interstate highway and receive 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from the 16 bidding companies? How many total companies are there? And receive 16 bids for the project, and there are 16 bidding companies, so the answer would be 16. How many companies are we choosing from? We're only choosing, we're planning to hire 4, so that is our k value. And is order important in this one? No, it's not, so we're going to use combinations. So we have 16. Our k value is 4. Let me do highlighters, this might help you. So 16. and k is 4. So here and here. So I have 16 factorial over 16 minus 4 factorial, and then the 4 factorial. Remember, you will use PEMDAS. So you would use the parentheses first. So this would give you 16 factorial over 12 factorial times 4 factorial. So 16 times 15 times 14 times 13 times 12 times 11, da 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 da, all over 12 factorial. And remember that 4 factorial, 4, 3, 2, 1. So those will cancel, and if you multiply those, you will get 1,820 different combinations. All right. Now I forgot to tell you, I want you to know it by hand, and then we can also use the calculator. Let's do the calculator for that first example with ice cream. Okay. So as long as you know your n and your k values, all right. Let me tell you the commands. Math on the far left. Okay, you're going to go on the top menu, PRB, probability. And then you see number 2 is permutations and number 3 is combinations. And then I'm going to do 15, choose, go to the right arrow and press 3 and then enter. That was the 455 for the ice cream one. Go ahead and try the bidding companies one. Go ahead and take 20 seconds to enter your calculator, and then press play when you're ready. Remember, the calculator trick is if you're doing multiple ones, you're going to press second enter, which basically repeats the entry, and you can go left and just change the numbers. So 16, delete, 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 16, choose how many companies? 4. 1,820. So let's write down the calculator commands so you have them. Let's do it over here. We have space. So we clicked on math, then probability, and then we choose the one that said NCK for combination, and just insert numbers, and then also just press right to move over. Okay, so that's how you use your calculator to complete combinations. That was learning target number 1. Learning target number 2, we're going to use combinations now to calculate probabilities. The focus of this chapter is probability. Recall that when a chance process results in equally likely outcomes, the probability that event A occurs is the probability of event A is equal to the number of outcomes, that says of, let's try that again, of outcomes in event A over the, I'm going to change colors to emphasize, total number of outcomes in the sample space. I just want to point this out. I think it's pretty obvious, but probability is basically a fraction. Do you see that? The last learning target, we were just kind of getting a total there, and we can actually figure out the probability of combinations by making it a fraction. So number 3, you can use the multiplication, counting principles, and what you have learned about permutations and combinations to help you count the number of outcomes. Let's try this one here. Example number 2a. Consider New York Jersey's Pick 6 Lotto game from the previous example. What's the probability that a player wins the jackpot by matching all 6 numbers? Okay. I'm going to divide this in half because we're going to need some space. All right, so again, I want you to think about this. And if you don't know, that's okay. That's the cool thing about statistics. It's kind of like real life example. When they do the lotto, they just pick numbers, right? Maybe you've seen it. It's this really thing, and it has like these balls on it, right? And the balls come out, and what they do, it doesn't matter what the numbers are. They'll say 35, 16, 18. In this case, there's 6 numbers, but what I'm trying to point out is that these numbers that they pick out, the order doesn't matter. And what they do is when they list the winning numbers, like, oh, when you want to win millions of dollars, they always put it from smallest to greatest, just to help organize the numbers. Okay, so what I just want to clarify is because the question you have to ask is order matter? And the answer in the case is no. So if it's no, then you just do a what? Combination. Let's write out the probability notation. Probability that you win the jackpot is that the number of ways to choose all 6 winning numbers and change colors over the total number of ways to choose 6 numbers from 1 to 49. Okay, in black there, there's only 6 winning numbers, and you're choosing what? All 6 of them. Okay? That's the numerator. Now, the denominator, what is the total? Well, how many numbers are we choosing from? There are a total of 49 numbers to pick from, and we're only choosing how many? 6. Okay, so you can do this by hand or you can do this by calculator. I want you to be able to be comfortable with the formula and the calculator. So 6 choose 6 equals 1. Right, from 6 numbers, there's only one way to arrange it. Well, whatever I put out there, it's a winner. Okay, so now 49 choose 6 numbers. The total of that is 13,983,816. So there's only one way. Oops, try black. $83,816. Now, I guess we didn't need that line, did we? Wow. Now, if you actually do the calculations on this, 0.00, count 1, 2, 3, 4, 5, 6, 7 zeros. Okay, so very, very unlikely. 1 in a 14 million chance that you will win this Pick Lotto 6. Okay? So again, how do we do the probability? You got to think order matter. No, then you have a combination. Well, how do you win? That's the number of ways to choose. That's the numerator over the total. Okay? All right. Go ahead and try this one here. Example 2b. See if you can figure out the n, the k. Can you write out the probability model? Can you use the notation and then see if you can get an answer and then press play when you're ready. What else for lunch? Your school cafeteria has purchased enough food for 12 different lunches. over the next few days. 5, which includes some sort of pasta. And due to a holiday on Monday, there are only 4 days this week. The cafeteria workers plan to randomly select 4 different lunches from the 12 lunches to serve this week. What is the probability that all 4 meals this week will include pasta? Let's write out the probability model in words. This might help us figure out what we need to figure out. So what's the probability that 4 of the pasta lunches are selected? Pasta lunches selected. Okay, in the numerator, we want the number of ways. Well, what are we trying to get? 4. 4 different lunches. Well, 5 of the which include some sort of pasta. So number of ways, 4 pasta lunches out of 5. Right? Because there's 5 days, and there's a holiday, so there's only 4 days, and we want all 4 of those days to basically be pasta lunches. Basically, what we're trying to say is, what's the probability that we can get 4 pasta lunches in a row, right? Okay, here is our total now. So I want you to focus in blue. We did 5, and then there's only 4. So I'm going to circle those numbers, 5 and 4. That's what I did in blue in the numerator. Okay, let's try the denominator now. This one, we're choosing from 12 lunches to serve over the week, but we're picking or choosing 4 of them. So we really want basically just the total number of ways to choose 4 lunches from all lunches. Okay, so from the words in blue, the order doesn't matter in which we pick them, right? I can pick pasta number 1, maybe that's marinara red sauce, right? And then pasta number 2 is green sauce, and then, I don't know, pink sauce, and then blue sauce, right? It doesn't matter the order of the color. All that matters is I just picked pasta, right? So from the 5 days, I'm choosing that 4 of those days will be pasta. Okay. And then the green is going to be 12. From the 12 different meals, we want to choose how many? 4. Let's go ahead and do this by hand. And then I'll do it by calculator and you'll see the answer. So if you want to pause and try it, go ahead. Or if you want to do it with me, we'll do it. So here, this one is NCK. So our formula is going to be n factorial over n minus k factorial times the k factorial. Let's work in blue because that's the numerator. So I have 5 and 4. So this will essentially be 5 factorial over 5 minus 4 factorial over 4 factorial. And again, I'm just trying to work on the blue, the numerator. So this would be 5 times 4 times 3 times 2 times 1. 5 minus 4 is just 1 factorial. 1 factorial is just 1. So then you have 4, 3, 2, and 1. And if you simplify that, you're just left with 5. So that was the numerator. 5C4 is just 5. Let's choose the denominator now. So same thing. N, K, 12 is our n value. 4 is my k value. N factorial over n minus k factorial, and then k factorial. And then n is 12 over 12 minus 4 factorial, and 4 factorial. So this would give us a 12 factorial over 8 factorial times 4 factorial, which would be 12, and then 8, 7, 6, yeah? And then over here, this will just be the 8 factorial, and this one will be the 4 factorial. So that one's gone, so we're just left with the, let's do green. 12 times 11 times 10 times 9, all over 4 times 3 times 2 times 1. And we will get an answer of 495. And if you put that as a decimal, you would get 0.010 approximately, which is around, 1%. There's a 1% chance out of 12 meals on a 4-day lunch that we pick pasta every day. Let's check our calculator. All right, so I'm going to use the numerator, parentheses, math, probability, NCR. This one's going to be 5 right, 4, close the print. Okay, so notice how I didn't get out. Just press delete and then press right arrow. Then the cursor kind of gets big. Close parentheses divided by 12, choose 4. Right arrow. And I get 1 out of 99 to get that stuck, math, and then number 2 to decimal. 0.0101. So 1.01% chance that that would happen. And that is learning target number 2. Let's move on to learning target number 3. Target number 3, we're going to use the multiplication counting principle and combination to calculate probabilities. I don't really have any notes, so we're just going to do examples, okay? This is just example 3, I believe. Were there selection shenanigans? Shenanigans just kind of means like, is it shady? Is it a drama? Are they above reproach? Something like that. The student council at local high school consists of 10 juniors and 30 seniors who are advised by a teacher. The State Association of Student Councils is holding a conference and the school has enough funds to send out only 6 students. The student council advisor decided the 6 students would be selected at random to go to the conference. The advisor conducted a drawing one night after school and announced the results the next day. 4 juniors and 2 seniors would go. The seniors were concerned that the advisor may not have used random chance to decide because so few seniors were chosen, right? Does that make sense, guys? 10 juniors. You would think small amount of juniors and a big number of seniors, you would expect more seniors to kind of be picked, right? So here's the first part. Find the number of ways in which a randomly chosen group of 6 student members could result in 4 juniors and 2 seniors being selected. Okay, so let's think about this. First, we're just going to focus on juniors. And if this was true, okay, this is my K value. And how many total juniors are there? There is, what, 10. Okay, so this would be 10, choose 4. Because we're trying to figure out the number of ways in which a randomly chosen group of 6 council members will result in 4 juniors and 2 seniors being selected. So remember, it's a combination because do we want the order to matter? No, it doesn't. I just want to pick from these 10 juniors, then I get, I'm going to pick 4 of them. Okay. Now, I drew a blank because these events are independent. It doesn't matter how many juniors on the left side I pick and then the seniors. The idea is that we can multiply these probabilities. That's the multiplication counting principle. Okay, let's do the same thing over here for seniors. Seniors, how many total are there? There are 30. So I have 30 choose, and how many will go? that's my k value in green, that would be 2. All right, let's do it by hand and then check our answer by calculator. So CNK, which is 10 and 4. And my formula is n factorial over n minus k factorial, and then k factorial. That's a 10. So I have 10 factorial over 10 minus 4 factorial, and then 4 factorial. So this would be 10 factorial over 6 factorial, 4 factorial. And this would be 10, 9, 8, 7, 6. And the 6 factorial would be 6. And then the red would be 4. So of course all of these are canceled, and then you're just left with that. So there in blue for juniors, if you did the math on that one, that would be 5,040 divided by 24. Let's see. That would be 210. Okay, let's do the seniors now. So the seniors is C, N, K, and 30 and 2. So again, start with the formula. Always, 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 always. And we substitute it in. So 30 for N, and N minus K is 30 minus 2. And then you have the 2 factorial. And then you have 30 times 29 times 28. And then this 30 minus 2 is 28 factorial. And then the red here, you just have the 2 factorial. Just 2 times 1, right? So these would cancel. And you're left with 39 times 29. 30 times 29 is 870, and divided by 2 is 435. So there's 435 ways to arrange 30 seniors, and you're going to choose 2 of them. And if I multiply those, I will get an answer of 91,350. There are 91,350 ways to select 4 juniors and 2 seniors to go to the conference. Let me double box that. Okay? All right, let's do 3B now. Find the probability that a random selection will result in 4 juniors and 2 seniors being chosen for the conference. Okay, so let's write this out in words. I want the probability that 4 juniors and 2 seniors are selected at random. Selected at random. Okay, so my probability would then be the number of ways. I wanted blue. Boop. Magic. Number of ways to get 4 juniors and 2 seniors. Okay, that's my numerator. That's what I want. And then in green will be the what? Total number of ways to choose any 6 student. Okay, so in blue, to get 4 juniors and 2 seniors, we just did that in the last problem. I'll just abbreviate it. I'm choosing 10 juniors, and I'm choosing 4 of them. And then I'm going to pick, out of 30 seniors, I'm going to choose C. I'm going to choose 2 of them, right? Because we already did the math on that. But the total... I should have done that in blue again. Sorry. Magic! Okay, the total number of ways is if I choose from how many total students? 40, I choose what? I'm going to choose 6 of them. Okay, so now we already chose this math right here is this number. Yes? 91,000. So we can do some less math. The problem was kind of broken up for us in that way. Where's my light blue? Okay. So that number is 91,350. Okay, now I just need to do 40 choose 6. 40 choose 6. Let's do our math over here. N value is 40 and my K value is 6. Formula! Always write it out every single time. Super helpful. Okay, so your N value is 40, and your 40 minus 6, and then you have 6 factorial. So this would be 40 factorial over 36 factorial times 6 factorial, and that's just going to be 40 times 39, 38, 37, 36, and da-da-da-da. And you have 36 times da-da-da-da-da, and 6, 5, 4, 3, 2, 1. And these will all go away. So if you multiply all of these, you will get 3. Here, I'll just break it up for you. The numerator would be 2,760,000. Whoops, sorry. 2,763,633,600 all over 720. And this would get you a number of, we can divide those two, 3,883,380. Okay, so that is now my denominator. Okay, now if you divide those two numbers, you get approximately 0.024%. There's a 2.4% chance of selecting 4 juniors and 2 seniors. From how many students? From 40 students. Pretty small. I don't know. Is that advisor having some shenanigans? All right, let's take a look at C here. Based on your answer to question 3B, is there convincing evidence that the selection process was carried out by random chance? Explain. Okay, so I'm just going to underline this one, and we've talked about this before. We didn't give you a set number, but convincing evidence is you want a number that's less than 10%. If it's less than 10%, then we call this convincing evidence against. Convincing evidence against. Okay, if it is greater than 10%, then we would say no convincing, not no, not no, no convincing evidence. Okay, so based on what do we have? So we would say this would be a yes, this would be a no, right? So we have yes, because our number is what? Less than 10%. There is only about 2.4% chance that a random selection would result in 4 juniors and 2 seniors being selected. And we kind of learned this earlier in chapter 4. So what would we do? Would we just have the advisor keep selecting until it sounded like we had no convincing evidence that this was some shenanigans or something shady or drama behind the scenes? No, we would just use simulation. We can use the probability of the computer. Okay? All right, go ahead and try example number 4. How many ways can you set up an iPod playlist? You try it out and then press play when you want to see the answers. How many ways can you set up an iPod playlist? Janine wants to set up a playlist with 8 songs on her iPod. She has 50 songs to choose from, including 15 songs by some band I don't know, One Direction. Janine's iPod won't allow any song to appear more than once in a playlist. 4A. How many different sets? Okay. Notice that one does not say probability, so it's not a fraction. My answer is just going to be some big number. How many different sets of A songs are possible for Janine's playlist? Assume that the order of the songs doesn't matter. Okay, so if the order does not matter, then it is a what? It's a combination, right? Okay. What is our total in this case? Well, the total is the 50 songs to choose from. N equals 50. And how many songs are we choosing? We are choosing 8 songs. So we are choosing 8 songs. So our formula, n factorial over n minus k factorial n factorial. And n is 50. And then 50 minus 8. And 8 factorial. So 50 over 42 factorial, 8 factorial. So 50, 49, 48, 47, 46, 45, 43, 42, 41, blah, blah, blah. Over 42 would be here. And then the 8 factorial. Just one less, right? And then these would cancel. So the total number is 500. If you multiply all those out, 536,838,650 different 8-song playlist. That is a lot of shuffling, right? That's essentially what you're asking the iPod to do. Okay. How many 8-song playlists contain no songs from One Direction? Okay, so let's think about this. There are how many songs total? Total is 50. And we went no songs by this group. But how many are, so it's kind of like yes, One Direction plus no One Direction. Does that make sense? It's a complement rule. So how many songs are One Direction? There are 15. So 15, and then you just subtract. That means there are 30. That's 15. There are 15 songs that are not by One Direction. So then we're doing essentially the same thing. So how many songs are we choosing from? We're choosing from 35 songs. These 35 songs have no One Direction. And we're choosing how many of these? Still 8. So C 35, 8. 35 over 35 minus 8 is 27 times 8 factorial. And we'll just put that on our calculator. 35, choose 8. Math, probability, 35, choose 8. And you're going to get this huge number. 23,535,820. I can't write. 23,535,820 different. I can't spell C. Different 8-song playlist with no One Direction songs. Okay, maybe you don't like the One Direction music, whoever they are. Okay, what's the probability that none of the 8 songs is by 8 Direction? Let's write this out in words, and that might make sense, okay? So we want the probability that there is no songs by One Direction. Okay, so basically we want the number of 8-song playlists with no One Direction. And then we want the total number of 8-song playlists. Guess what, guys? We basically just did that in the last problem. Isn't that kind of nice? All right, so let's just use our highlighter over here. So no One Direction, that would be this number. 23,535,820. And then the total number of 8-song playlists, that is just going to be what we did in the first one, that number. 536,838,650. And if you divide those two numbers, you will get 0.044. There is a 4.4% chance of getting a 8-song playlist with no One Direction songs. This is our answer for 4C. All right, last one. Find the probability, okay, this is a review problem. Find the probability that exactly 2 of the songs on the playlist are One Direction. Okay. So, let's write this out in words, and this might make sense to you. Okay. How many One Direction songs are on the iPod? There are 15. And we need to choose, I don't care where they come up, but it says how many? Exactly 2 of them. So 15, choose 2 of these. Okay, now, this means that the first 2 songs, let's write 2 songs, and then the other 6 songs, I don't want to be. So this is yes, One Direction, and then this is no One Direction songs, okay? So how many songs are not One Direction? Well, the answer would be 35 of them. But I need to choose 6 of them. So the probability is a multiplication of these 2 independent events, okay? So if you choose these 2 independent events, you would get, you can just use your calculator, 105 times 1,623,160. And if you multiply those, you will get 170,431,800 ways to get exactly how many songs? Exactly 2 One Direction songs on the playlist. Okay, now, this was the, if you think about it, this was our outcome. That's the favorable outcome. Let's write that. Because that's what I want, right? But I have to think about it over the total. So again, total 8-song playlist. And this one I want exactly 2 One Direction songs on the 8-song playlist, okay? So let's just use our highlighter again, and then we're done. Okay, so exactly the 2 songs is what we just found out. Okay, where is the total number of songs? The total number of songs is up here, 536 million. So 536 million, 878,650. And if you divide those, you will get 31.7%. Now, if you ever were asked the question, is there convincing evidence? And what would we say in our last one? If it was more than 10%, we would say there's no convincing evidence that this is like crazy. I'm going to write that. No convincing evidence that this is weird. Because, 15 out of 50 songs, you double that, that's 30 out of 100. That's 30% of the songs are One Direction. So there is a 31.7% chance of getting exactly 2 songs on a, only 8-song playlist. Okay? All right, let's review. We did computing number of combinations. We calculated combinations with probabilities now, so that's a fraction, right? And then if you have two outcomes, kind of like yes or no, like, songs by One Direction or not, or juniors and seniors, you would just kind of multiply those. And that was lesson 4.8. We'll see you guys.
We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.